Statistical analyses are very often concerned with the difference between means. A typical example is an experiment designed to compare the mean of a control group with the mean of an experimental group. Inferential statistics used in the analysis of this type of experiment depends on the sampling distribution of the difference between means. Normally रिसर्चर्स का फोकस जब उनका वास्ता जो है वो दो डिफरेंट पॉपुलेशंस के साथ हो और या उन्होंने मवासना करना हो एक पॉपुलेशन का कि दूसरी पॉपुलेशन के साथ, तो वहाँ पर हम सैम्पलिंग डिस्ट्रीब्यूशन ऑफ डिफरेंस बिटवीन मीन्स जो है वो यूज़ करते हैं किसी भी एक पॉपुलेशन को ऑथेंटिसाइज करने के लिए। इसमें से नॉर्मली एक पॉपुलेशन जो है वो कंट्रोल ग्रुप कहलाती है और दूसरी पॉपुलेशन जो है वो एक्सपेरिमेंटल ग्रुप कहलाती है। कंट्रोल ग्रुप जो है उसके जो कैरेक्टरिस्टिक्स जो होते हैं वो पहले से नॉन होते हैं या उनकी इंफॉर्मेशन होती है और उनका मवासना किया जाता है एक्सपेरिमेंटल ग्रुप के साथ। नॉर्मली एक्सपेरिमेंटल और कंट्रोल ग्रुप जो है उसके जो शेप या कैरेक्टरिस्टिक्स जो हैं वो नॉर्मली एक दूसरे से आइडेंटिकल होने चाहिए। The sampling distribution of the difference between means can be thought of as the distribution that would result if we repeated the following three steps over and over again. The first one is drawing samples N1 scores from population 1 and N2 scores from population 2. Second, compute the mean of the two samples, that is x1 and x2. And the third, compute the difference between means, that is x1 bar minus x2 bar. The distribution of the difference between means is the sampling distribution of the difference between means. As you might expect, the mean of the sampling distribution of the difference between means is mu x bar 1 minus x bar 2, that is equal to mu 1 minus mu 2. इसका मतलब ये है कि अगर आपके पास दो पॉपुलेशंस हैं और उनके आपके पास मीन मालूम हैं, तो मीन जो हैं उन मीन्स की उन सैम्पल मीन्स के डिफरेंस के बराबर होंगे। फॉर एग्जांपल, द मीन टेस्ट स्कोर ऑफ ऑल 12-year-olds in a population is 34 and the mean of 10-year-olds is 25. If numerous samples were taken from each age group and the mean difference computed each time, the mean of these numerous differences between the sample means would be 34 minus 29, that is 9. From the variance sum law of the independent variables, we know that sigma square of difference between means is equal to sigma square x1 bar plus sigma square x2 bar. It means that the variance of the sampling distribution of the difference between means is equal to the variance of the sampling distribution of the mean for population 1 plus the variance of the sampling distribution of means for population 2. As we know that the variance of the sampling distribution of the mean is sigma square x bar is equal to sigma square over sample size. Since we have two populations and two sample sizes, we need to distinguish between the two variances and sample sizes. We do this by using the subscript 1 and 2 for n1 and n2. Using this convention, we can write the formula for the variance of the sampling distribution of the difference between means as variance of difference between means is equal to variance of first population divided by sample size 1 plus variance of second population divided by sample size 2. Since the standard error of a sampling distribution is the standard deviation of the sampling distribution, the standard error of the difference between means is sigma 1 square divided by n1 plus sigma 2 square divided by n2 whole under root. In case when the sample sizes and the standard deviations are equal for the two samples, such as sigma 1 is equal to sigma 2 is equal to sigma, and n1 is equal to n2, and we can write as simple n or sample size. The above equation can be written as sigma x1 bar minus x2 bar is equal to population variance divided by n plus population divided by n, and by solving this, ultimately we can have sigma under root 2 over sample size. As we already know that when the sampling is done without the replacement and the population is finite, then the following formula is used to calculate the standard error. Normally, we multiply the formula being used with replacement by the factor of finite population correction factor. So the standard error becomes square root of sigma 1 square divided by n1 plus sigma 2 square divided by n2 whole under root multiplied by under root of n minus n divided by n minus 1. Let's solve the exercise 1, in which population 1 has a mean of 20 and a variance of 100, whereas population 2 has a mean of 15 and variance of 64. You sample 20 scores from population 1 and 16 scores for population 2. We need to know what is the mean of the sampling distribution of difference between means. In this question, we have mean of first population, that is 20, mean of second population, that is 15, variance of first population 100 and variance of second population 64, whereas sample size for first population is 20 and 16 for second population. In order to find the mean of the sampling distribution of difference between means, we will use the formula mu x bar minus x bar 1 minus x bar 2 is equal to standard mu 1 minus mu 2. So we just need the mean of first population and mean of second population to find out this mean of the sampling distribution of the difference between means, and in this case it is 20 minus 15 and the answer is 5. In exercise 2, population 1 has a mean of 20 and variance of 100, whereas population 2 has a mean of 15 and a variance of 64. You sample 20 scores for population 1 and 16 scores from population 2. we need to find that what is the variance of the sampling distribution of the difference between means. When we look at the given data, we have mean of the population 1, 20, mean of population 2, 15, variance of first population 100 and variance of second population 64, whereas the sample size for population 1 is 20 and sample size for the second population is 16. We know the formula to find out the variance of sampling distribution of the difference between means, that is equal to sigma 1 square divided by n1 plus sigma square 2 divided by n2. As we have all the parameters, by putting the values we can find the variance of the sampling distribution as 9. This exercise 3 is your classwork as well as exercise 4 in the upcoming slide. In this question, as per previous exercises as we have done, we need to find out the mean and standard deviation of the sampling distribution of the difference between means. We use the two formulas to find out the desired answer.